Alright, welcome back everybody. My name is Dustin, and in this video, we're going to start looking into how we're going to handle the undo and redo functionality in our engine. There's many ways that we can handle this. We could use the command pattern to achieve this. This would involve using an interface for the commands and creating child concrete classes that would implement these commands. The interface would look something like this. We would have an interface called ICommand. The interface would only have pure functions that would have to be implemented by the concrete child classes. It would contain the undo and redo functions. This would ensure that all the child classes have the same functionality that we can follow when we use the command manager. Let's take a look at a couple of the concrete classes that we would use. So here are the add tile command and the remove tile command. They are both children of the ICommand interface. They also override all the functionality of the interface to handle the undo and redo and execute functions. The actions performed by the add tile command would be as follows. The undo function would remove the newly added tile, and the redo function would add the tile back that was just undone. It would follow the same idea for the remove tile command, however it would be the opposite. There would also be a command manager. The command manager would then actually control when the undo and redo actions are performed. The command manager would also hold onto all the commands or actions that have been performed in two separate stacks, undo and redo stack, as you see here. These stacks would be shared pointers of the ICommand interface. This would allow us to use polymorphism where we would only have to use the overridden functions. There would be an execute command function that would take in a pointer of the interface class. The execute command would reset the redo stack to empty, call the execute function of the passed in command, and then push that command onto the undo stack. The undo function would first check to see if the stack was empty. If not, it would perform the undo function of the command that was on the top of the stack. And then it would push the top command onto the redo stack and then pop it off of the undo stack. The redo functionality would do the same thing as the undo function, however it would be the opposite, so the same idea. Then we would have a clear function that would clear both the stacks. We would want to probably do that when we're changing the scenes, because that's how I'd like to control it. I want to control it based on the scene itself. So this would be a tried and true way of handling this undo and redo functionality. But we're going to take a different approach for our engine. For our engine, we're going to use std variant and create an interface through the use of C++ concepts. This will allow us to use a different kind of polymorphism without using any virtual functions. Here are some of the advantages for using std variant for polymorphism. std variant uses value semantics, so there's no need for any dynamic allocations. There's no need for base classes or classes to be related at all, and we'll handle all of the underlying issues that could arise with concepts. There are some disadvantages to using std variant. All of the types used must be known at compile time. In order to add new types, they must be added to the source itself. So that would prevent us from being able to use any plugin functionality. So if you wanted to add a new module or something, you would have to actually change the underlying source. You couldn't just use the ICommand interface that we discussed before. There could be some memory waste. std variant will also use the size of the largest type in the variant plus some discriminant value to keep alignment correct. Another disadvantage would be that we'd have to create a separate visitor function or separate visitor command for each type. However, we'll handle that with the use of templates and allow the compiler to create them for us. There are probably some other disadvantages that I'm missing. However, that's all right. We can always change our implementation later to the ICommand interface and do it that way if we find it's not working the way we want or overly complicated. Or if you would like to use the command pattern stated earlier with the ICommand interface in your engine, please feel free to do so. I could go over that implementation in another video if desired, but it's pretty straightforward. I think you guys would be able to figure it out. And if you do end up using that instead, let me know in the comments below if you want to use the interface with the polymorphism, with runtime polymorphism with virtual functions, or you want to do it this way with std variant and using concepts. All right, so let's get started. Okay, so the first thing I'm going to want to do is create the abstract command manager class. We'll start with the command manager and then we'll work our way towards the actual types and commands after that. So this will be editor specific. We don't need this functionality in the core, so we can use it here, and then we'll create a new folder and we'll call this commands. And inside of here, we'll create a new file, add new file, and we'll call this abstract command manager.h. Yep, we want to edit in. So we got to add our pragma once. And we're going to have some includes. I know we're going to be using std variant, so we're going to want to include variant. And we're also going to use a stack as well. So kind of like a hybrid between the ICommand that we showed earlier and the variant that we're going to use. And this is going to be in our editor namespace. Awesome. So the first thing I want to do here is actually create our concept interface. We want to use this so any type that we pass into our variant has these specific functions implemented or must have these functions implemented. So we want to say template type name T, or you can use class concept, and I'll call this command type is equals requires T. We're going to have two separate ones here. We're going to say T, and it's going to be undo. So each type that we use must have this undo function. And we have to say std, same as, and it's just going to be void. So the return type is void. And we'll have another one here. And we can just copy, actually we can just copy this whole thing. Copy this. Paste that in, and change this to redo. Okay, so that's our concept. It's pretty straightforward. So what we're saying is we're going to have command types, and these types must have these two functions. Okay? So now that we have that, we can create an alias for using our new concept with the std variant. This will ensure that all types passed into our variant are of the command type that we declared above. So template command type commands. Now this needs to be variadic because our variant will also be variadic. So we'll say using, and I'll call this var commands or variant commands, std variant cmds. Cool. We're also going to want to create another alias for the command stack. This command stack will be a stack of var commands. So it'll be template command type, then using command stack equal to stack var commands awesome. Let's make this a bit bigger. Cool. All right, now it's time to start our abstract command manager class. This will also be a template class. So template, and it will be of command type. Or this way, yeah. Then class, and we can say abstract command manager. Now, I usually put the private section first, but this is one of those situations or one of the cases where I want the usable public functions to be up front for the user. We'll put the implementation details below. So I'll say public. And for the public functions, we're going to have a few functions here. We're going to have the undo, redo, clear, and execute function. So let's say void, undo, redo, clear, and then we'll have our execute function, and we'll say void execute. That's going to take in var commands. That's going to be a reference. And we're going to say undoable variant. All right, and we're going to have some private stuff as well. Control KD. So now for the implementation. The first we're going to have is the run undo function. This function will take in a var commands reference, which is just the std variant of command types that we stated above. This is the function that will use the std visitor to call the necessary operation for the set type or the passed in types, or the set type in the variant, if that makes sense. So we'll say void run undo, and it's var commands reference undo variant. Cool. If you guys want, you can do it all in your H file. I'm going to make an INL file for this. So now we're actually going to want to create the undo implemented function. So it'll be run undo impl. And this function will be the actual operation itself that's performed by the std visit. So it will take in the command type that we want to use. And all it will do is call the undo of that type. So for this one, we actually want to send in a template command type t command void run undo impl t command undo. All right, and lastly, we're going to want to have two stacks, the undo and redo stacks, and we can make another private section for that. And I'll just say command stack m undo stack, copy this down, m redo stack. Awesome. So now we're going to want to create our INL file. So in here are commands, add new file, abstract command manager.inl. I think I spelled that right. That's going to include our abstract command manager, namespace, Scion editor. Cool. Let's go back into our manager here. And we'll just make this function. It will make it right here in the .h file. That's fine. I just want to make it and then take it, put it in the INL file, paste that here. Cool. Go back into here. And down here we can include editor commands .inl. Now it should see it if it put it in the CMake list. Let's take a look, make sure it's in there. So it only has the command manager, INL as well. All right, let's actually make this into a new section here. And it's not going to do anything. It's just so we can filter it for ourselves. The CMake doesn't give a crap really. So now we can actually see if this will be all made in the .inl, and it will. So let's copy them all or create them all in there. Awesome. So let's go in to the INL file. Cool. So it didn't make the impl over here. It made it down here. But I want to take this and put this in here. Cool. Well, that'll just be our undos. So now we have to do our redo as well, which is just the same thing as these. So we can just copy these both here. Paste, change this to run redo. Run redo. Cool. Make them both. Awesome. Cool. So we got all our functions that we need. So up here, we have that. Good. So all we need here is, we can just do the easy ones first. So here, the run undo impl, we can just go undo command dot undo. Copy this. Undo command dot redo. Cool. Now the run redo and run undo, we need std visit. So we go std visit. We can pass in a lambda, and we're going to want to capture a reference. And it's going to be auto val. And then say run redo implemented. That's going to take in val. And then undo variant. That's it. And we can copy this visit and go to our run undo That should have been a semicolon. Change this to run undo. Cool. That's it. See how simple that is? So all we're doing here is running our redo functions that is going to be part of our type that we pass in. And we're using the std visit to go to the type that's held in our variant and run its undo function. Cool. Okay, let's take a look at this execute function. So all we're going to do with the execute function is reset the redo stack. That's how I'm going to want to do it. So anytime that a new function is done, we're going to undo the redo stack. So m redo stack is just equal to empty. Then we say m undo stack dot push std move undoable variant. Cool. Our clear functions is going to do exactly that. We're just going to say m undo stack redo stack. And let's take a look at our redo. And our redo function, we're just going to check to see if it's empty. And if it's empty, we're just going to return. So if we go if m redo stack is empty, just return. If it's not empty, we're going to want to call run redo of the redo stack dot top. So whatever's on the top of the stack, we want to run our redo function. And our redo function is going to run the visit, and the visit is going to run the actual redo underlying function of whatever's held in that variant. Okay? And then we're going to want to go m undo stack dot push m redo stack dot top. And then we can say m redo stack pop. Cool. That's it. And we can just copy all of this because it's going to be the exact same thing for the undo function. And just change these all to undo. M undo run undo 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 redo is now undo. Undo is now redo. Pop it up and undo. Does that make sense? So if the undo stack is not empty, we come in here, we run the undo function, whatever's on the top of the stack, then we push that on top of our redo stack, okay? And then we pop it off of the top of the undo stack because it is completed. Awesome. Now that we have that implemented, we need to go and create some actual commands that we can undo. So let's go do that now. The first one I'm going to create is for the add tile tool or create tile. So let's go here. And in our commands folder, we'll actually make another folder. And we'll just call this commands, like that. Just a way to separate them. And we'll create another one, add new file. And in here, this will be the create tile tool commands.h. Apply. So we can just go pragma once. Add our namespace, Scion editor. Cool. Okay, so what do we need for the create tile? So we're going to need the registry that the tile was created in and a pointer to a tile object. Okay, so for the registry, I'm going to want to go namespace Scion core ECS and forward declare the registry. Registry. That should be a small e. Cool. Awesome. And we're also going to want to forward declare that tile that I was talking about. We have used the tile before in the create tile tool and the create rec tool. And we're going to have a create tile tool command. So we're going to say struct create tile tool add command. So we're adding the tile. And what do we need? So we're going to need the registry. So we're just going to have a pointer to the registry. So Scion core ECS registry. And I'm just going to say p registry. Registry. And this can just be null pointer by default. And we'll do some checks to make sure that it's correct. That has to be a pointer, sorry. And we're also going to want to make a shared pointer of the tile. So we go std shared pointer of a tile. And we'll call that p tile, and that will be null pointer. And we're going to need to include memory up here. Cool. All right. So now that we have the struct, we need to make sure that we have those two functions, the undo and redo, that we declared in our concept here. Okay, so our command type concept needs to see these functions. Okay, so we need to go void undo and void redo. Now, what it actually does right now doesn't matter, okay? Having it actually do the undo function, that's not what matters right now. It's just getting it to work to see if we can get it going. Because there's lots to do, so let's keep it moving. So let's create a CPP file, add new file, create tile tool commands.cpp. Yep, we want to add it. Include create tile tools commands. Then we want to say namespace Scion editor. We're also going to want to include the core. So include the core ECS, and then we're going to want to have the registry. And we might as well include the components, core ECS, components, all components. And we're going to need the editor utilities. So editor, editor, utilities, editor utilities, because that's where our tile is declared. Let's include the entity as well. We're going to need that. And we might as well include the logger for now. So logger.h. And let's go and create these two functions. All right, so it didn't do it for us. That's fine, we'll just do it ourselves. Copy this. Okay, so we have our undo and redo functionality, and we're just going to log right now, Scion log undone create tile tool command. Copy this, go down, and just say redone. Redone create tile tool command. Okay. So there is some functionality that we have to put here, but let's not worry about that yet. Before we do that, I need to actually create, this is our abstract. We need to actually create the command manager that we want to use. So we'll create the actual command manager in here. So let's go add new file, and then we'll call this command manager.h. Add. All right, so this is just going to be a sort of wrapper class that we can use for all the necessary types needed for our manager. We'll only need to access the public functions, and by doing it this way, we can forward declare this type in the header file and then only include it in any CPP file that we want to use. So we can go, we need to know our types, so we're going to have to include all of our types here. So include commands, and it's going to be create tile tool commands, to do, add other commands as necessary. Cool. Then we can say namespace Scion editor. So let's create another alias, this time for the undoable command. This will contain all the types that we want to allow in our variant. So we'll be using undoable commands, and that's going to be equal to var commands. But in order to use var commands, we need to include, well, first we got to make this pragma once. I forgot to do that. And then we need to include our abstract command manager. Then we have our var commands. And for now, we're only going to have the create tile add command. But in here, we're going to want to add other commands. I will say command types. Yeah, that's better. Cool. So now that we have that, we can create our command manager, and that'll be class command manager. That's going to inherit from public abstract command manager of the create tile tool command. And then we'd also add other types. And that's it. That's all I need to do for my command manager, because all the public functionality is all I need to access. These functions that are public is all I need to access. So in here in my command manager, I just list the types that I want. This will just basically be a type holder. And then I will forward declare my command manager in any file that I want to use this in any H file, and then use the CPP file, or actually include it in the CPP file. Okay, so that's it for our command manager. The way that I want to control this for now is in the scene manager. So let's add this to the scene manager and see if we can get that to work now. Okay, so let's go into our scenes, scene manager here. And do we have any forward declares already? Yeah, so I'll just go class and I'll say command manager. And then down here we have our tool manager already, so just copy this down. Change this to command manager, MP command manager, like that. And then we can create a simple getter function down here, the same way we did the tool manager. So we just bring this down one, copy this down, change this to command manager, copy this, get command manager, like that. And we'll make this function. And just like our tool manager, we're going to want to do the same thing. Let's copy this all here. So we're going to check to see if it is null pointer. If it's null pointer, we will make it, and then check this again to verify that it's not null pointer, and then pass dereference value. MP command manager, copy this, change this to command manager. And we're going to have to include that up there. We'll get to that in a second. Cool. So there's our command manager. So let's go and include this up here so it knows what that is. And we'll say include editor commands command manager. Cool. Let's just build and make sure that we didn't miss anything along the way. If we did, we'll fix any issues that we have. Awesome. So the rebuild succeeded. That's great. So let's actually go now to our create tile tool and see if we can add this in. So let's go there now. So that's in our tools. Well, first thing, let's go to our manager, tool manager. And by default right now, we're automatically setting it to rect. We're going to change that just to create tile for now. And then go into our create tile tool.cpp. And we're going to add in our command manager. Editor, commands, command manager. Cool. We have our mouse tile here, and our mouse tile is of type tile. And we can actually pass that in, but we don't want to use the same shared pointer because we'll just make a new one. So what I would like to do is down here, go auto create tool add command. That's equal to undo doable commands of create tile tool add command. Then we're just pass the registry in, so p registry. And that's going to be equal to the scene manager. Scene manager dot get current scene get registry pointer. Okay, so we're going to need that stuff up here. So let's add that in. So in here we go include editor, scene, scene manager, and scene object. Go down. So we have our registry pointer. Now we need to do our tile. So p tile is equal to std make shared of a tile. Make shared tile mp mouse tile. All right. So hopefully that makes sense. So what I'm doing is I'm creating a undoable commands, which is underneath is a variant of Scion editor create tile tool command. Okay, now we're sending in our mouse tile. So we're creating a new tile, new shared pointer here of the reference for this tile. Okay. All right. And then we can say we need to get the command manager. So we do have that getter function in the scene manager. However, if we go back to the scene manager here, we can actually create another macro. We can go define command manager is equal to scene manager dot get command manager. And then we can just call this directly. Let's get rid of the semicolon. Command manager. Bring this back into here. So command manager. And I'm going to want to go execute. And I'm going to say create tool add command. Cool. Let's try to compile that. Awesome. We're looking good, looking good. So basically, we're just creating a command. So we just added this tile in here. So we created a new tile, created a command, and everything that we just did, adding this in here to our command manager. This will clear the redo stack and add it to the top, okay, of the undo stack. So now we need a way to actually undo and redo this. And for now, we can just put that into our tile display or tile map display. I think that's a good place to put it. And let's go all the way to the, we have to add in our command manager. So we have our scene manager editor right here. Let's go include editor, commands, command manager. Cool. Go down to the bottom. This looks like a good place. We'll just do it directly at the bottom here. And we can say, do we have a keyboard? Yeah, so we need to get the keyboard. So we can go auto reference keyboard equal to, I believe we have the input manager here. Manager dot get keyboard. Cool. Then I can say if keyboard dot is key pressed. I'm going to say Scion key L shift for now, and or no, not L shift, so left control. L control and keyboard dot is key just pressed Scion key Z. Then I'm going to want to do something. But in here, we're going to also check to see if the shift key is pressed. So we can go if keyboard dot is key pressed. Scion key L shift. If the key is pressed, I'm going to want to do the redo. So command manager dot redo, else undo. Command manager undo. All right. So we did a lot of work there. Let's see if that works. All we need to see is, are we printing this message right here? Because if we're printing this message, that means when we added it here in the create tile tool, it went through all the correct channels. And then when we do the undo, it does the visit and the redo and all run undo implemented and all of that. If it gets to there, that means it worked. Awesome. So it's compiled, it's open. Let's go to a scene. And we need to, do we have any tile sets? No. So we need to run this if it will run. All right. So if you remember from before, we have this here that loads our script. This is a little testing I was doing. There's a bug in our wrap functionality where it's not wrapping correctly. So I think I have a fix for that, but I haven't pushed it yet. So I'll get around to fixing that shortly so we can actually just comment this out because I'm still using it. And open this. We want this one because I want it to load the scripts for me. Okay, so then we'll go here, load our scripts. I just want the assets. Oh, there that goes. Yeah, see, I'm doing some stuff there. So we'll just ignore this for now. Cool. Go back. Awesome. I should have my assets now. So let's go to our logs. Let's just clear these for now and add in some tiles. Tile details. Add a layer just for placing a few tiles. So we're adding a few tiles, right? So if I go my logs, I hit Control Z. Look at that. Undone, 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 redone, 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 undone, 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 redone, redone, redone. So it is working, guys. Okay, so our undo and redo stack is working. Now we're not getting rid of these tiles, and that's going to be your challenge. So your challenge is going to be to go through and figure out how we're going to undo and redo these tiles. And I'll go over it in the next video. Also, for an even bigger challenge, try to see if you can do it for the remove. So when we hit the right mouse button, it removes the tile. Handle the undo and redo for that. And you're gonna have to create a new type for that. And also do it for the rect tool. So if you can, give that a shot, create the functionality, or you have to create your new type. So let's go here. So we have our types here. Create tile tool commands. So you're gonna have to create another one. You might as well create another one in this file for create tile tool remove command, and then add that down here, right? And then create a new file for the rect tool, add and remove. The difference between the rect tool is it's not just one tile. It's multiple tiles, so you need to be able to keep track of all of them. I'll go over my implementation in the next video. So that's our undo, redo, and how we're going to do it for this engine. If you don't want to use STD variant, let me know in the comments below. And I'll show you guys how to do it with the interface, so we can use the ICommand interface instead. So this is the way that I'm going to do it. All right, that's it for this video. Give the challenge a shot. Please like and subscribe if you haven't done so already, and take it easy.